So thank you, sir, and a very warm welcome to all the participants present in this 5-day long faculty development program organized by Department of Computer Science and Engineering and Department of Computer Science and Engineering Artificial Intelligence of Institute of Engineering and Management, Kolkata. The FDP is based on emerging trends and challenges in cloud computing and IoT. And today we are so pleased to have with us Dr. Debashish De. He is a very renowned professor, and IEM has a very long association with Sir. Sir has been helping us with many different projects, giving us guidance throughout. So a very short bio of Sir for all the participants. So Dr. De is a professor in the Department of Computer Science and Engineering at Maulana Abul Kalam Azad University of Technology. He received his MTech from Calcutta University in 2002 and completed his PhD from Jadavpur University in 2005. Sir is a senior member of IEEE, a fellow IET member, and life member of CSI. Sir was awarded the prestigious Boys Cast Fellowship by the Department of Computer Science and Technology, Government of India, to work at the Heriot-Watt University, Scotland. He has received the Endeavour Fellowship Award for from 2008 to 9 by DEST Australia to work at the University of Western Australia, and the Young Scientist Award in 2005 at New Delhi, and again in 2011 in Istanbul, Turkey, from the International Union of Radio Science, Belgium. Sir has received the JC Bose Research Award from IET in the year 2016 and the very prestigious Shiksha Ratna Award from Government of West Bengal in the year 2019. Dr. De has established the Center of Mobile Cloud Computing for IoT applications. He has over 400 journals, 200 conference papers, 20 books, and Sir has filed 10 patents. So we can understand how rich the session for today is going to be like. Sir has about Sir has got a project sponsored by AICT, DST, WBDST, World Bank, to name a few. His H index is 45 and the citation goes up to a hefty number of 9,500 and above. Sir's research interests are in the field of mobile cloud computing, AI, IoT, and quantum computing, to name a few. So, without wasting your time anymore, I think if Sir starts speaking, we all will be more happy to listen to that. So, with that, I pass down the virtual mic to Sir. Over to you, Sir.
Thank you, Bavrabi madam, and thank you to Moutushi Singh madam for inviting me in this talk. And I just returned from UEM.
Yes, sir. We got the news. We were, hoping that you would come down here and we would be able to, meet and greet you and have a nice session.
I just came through IEM only.
Yes, yes. We got the news.
Okay. Yes. Okay. Let me share the screen here. I think today I'll be discussing. I think it's the last day, right? Last day of your FDP.
Yes, sir. Today is the last.
Yeah, fine. I think you have a lot of idea on the recent trends in cloud computing, right? And
yes.
So, what are the sessions? Can you just tell in a brief, madam?
Yes, sir.
What is covered here?
Let me just get back to you, sir. Just 1 minute. Hold on a minute,
yeah,
sir.
No problem. No problem.
Yeah. Sure.
So I think you have 4 5 days, 5 to 6 days workshop, right? 5 6 days workshop.
This is a 5-day long FDP, sir.
Okay.
Yes. So we had. Yes, most of them were online. We had a few offline sessions as well. So we had sessions on knowledge-based systems using IoT cloud, IoT analytics, resource management in cloud environment. And yesterday we had a session with Dr. Josna Kumar Mondor, and Sir has given a talk on security issues in IoT. So these are the topics that has been covered.
Sure. Today I'll be discussing on a topic called edge computing or mobile edge computing. So it is very interesting area in the age of IoT. This edge computing is a buzzword, and if you see the research trends in computer science in networking domain, at least 40% people are working in the domain of edge computing. So it is a new area, just evolved 4 or 5 years, last 4 or 5 years, and IoT and edge computing is progressing hand to hand. Today, next 1 hour I'll be discussing how this edge computing is playing major role in the area of cloud computing. We call it mobile edge computing. If the mobility is there, let me share the screen. Is the screen is visible?
Yes, sir. The screen is visible. The presentation is in full screen. So yeah.
Okay. So today I'll be discussing on the topic called mobile edge computing, right? And as he said, that edge is a new age of new kind of cloud computing, which is close to the human being or user. And the term edge is basically indicates the corner or the edge of the system. And computing is happening and the mobile devices. Basically, our mobile phones is also one kind of edge device. We call it mobile edge computing or mobile edge system, where the computing is happening in the mobile device and where the mobility is playing a major role. So, as you know that we are all now working in this. We believe in not a land phone, right? So everyone is using mobile phones, mobile devices, also the vehicles, the cars which is moving on the road. They also use this cloud computing, edge computing systems. So edge is one kind of cloud which provides us network services to the close to the user, right? So I have a center called Center of Mobile Cloud Computing. Am I audible right properly, or any noise is coming, or am I audible properly?
No, sir. You are clearly audible.
Okay, fine. So this is a Center of Mobile Cloud Computing where we can see that we have written a book in 2015 on CRC Press called Mobile Cloud Computing, where actually the mobile device data to the app is going to the cloud, and to these apps actually the user is accessing the cloud, right? And we can see that mobility is handled by the cloud. For example, nowadays if you want Ola and Uber, you can simply access the Ola Uber through this app, right? We have Ola Uber app, and through it we can simply access this Ola and Uber. And this provides the flexibility. So anything as a service, we are getting anything as a service, right? Where mobility is playing major role. The cloud computing, along with the mobility, gives us the flexibility to utilize the resources of cloud computing in a more handy manner. Handy means close to the user. I'll be because mobile using this mobile phone, we are getting the app, and through the app we are accessing the all the cloud data. So apps makes a revolution. I think nowadays everything is on the app. We are doing any kinds of operation, or rather everything operation to the this cloud operation only. And we can see the data mobility and vehicular data, mobile cloud sensing, drone mobility, everything in the smart city. Everything is happening in the cloud computing domain. Okay, so we can tell you that I can tell you the smart city respect. Say in case of Calcutta or Bangalore, if you see the average speed of the car, if you see the average city, vehicle speed, say Calcutta is say 35, and Bangalore is 40. That means Bangalore is more smarter in terms of mobility, because the cars or the edge devices, not only car, the device mobility means using your mobile device, how much you are moving per hour basis, the movement and the mobility fashion, everything is calculated. By that way, actually, the smartness of the city is calculated. So these are the various research areas as is shown in this figure. So now, if you see this mobile computing, mobile cloud computing, I just go to this slide. See, this is the cloud. This is the cloud. You can see only thousands, a few thousands of cloud. Hello. You can see
Sir,
only, yes.
Yes, just sorry for the interruption. I would request all participants to kindly mute yourselves. We will be opening the forum for Q&A at the end of the session. Sorry, sir, for the interruption. Please continue.
But no problem, no problem. See, there are thousands of clouds and few millions of fogs and billions of edge devices. And these edge devices, that IoT sensor, they're all working together in the edge. And by that edge, okay. And this edge device actually, that this edge device actually collecting the sensor data. And see, we have smartphone, right? We have smart watches, we have healthcare devices, and we have billions of devices which is working together. And this edge device is playing a major role. This edge device is playing a major role because all the users are using these edge devices. For example, these clouds, that where actually this your smartphone. Nowadays we have uh, oximeter in our smartphone. We have BP meter in the smartphone. We have uh, that pulse also oximeter and various kinds of all kinds of healthcare data. If you have any Apple smartwatch, or you can get all kind of body statistics, even the surface roughness or the texture of your skin, everything can be measured, right? So edge device in terms of healthcare makes a revolution. And what is actually happening from the body,
हो गया विनीशा हो गया
from the human body, we are actually capturing the data on the smartphones or the smartwatches or in your smartphone, and it is doing the computation. And that is the beauty of the system. Earlier we have seen our mobile phone has only 1 GB RAM. Nowadays mobile phone comes up with 16 GB RAM. I have mobile phone with 16 GB RAM, right? So that means the capability of the edge devices are increasing like anything, right? So this is the capability of the edge devices increasing. As a result, that our system performance, whether it is healthcare, whether it is agriculture, these edge devices playing major role for IoT applications. Why? Because it is working at the edge of the system, right? It is working with the user. It is working along with the IoT devices, right? Whether it's we can switch on or switch off our light using our app, whether we are doing any kinds of third-party operations, that fog node for this thing. Fog is something I can tell you. Fog is maybe your server at IEM college, right? And this cloud is basically the Amazon server, or I've heard that IEM also has cloud, right, madam? Probably, madam. IEM also have now cloud
Yes,
data centers.
yes, yes. We have a cloud.
Yes. So this morning also in our meeting, we have a lot of discussion on IEM cloud, and I think many students are getting access, but they're very costly in nature, right? And that is the reason we are getting the cloud as a service. We are just paying the service cost, not the full cost of the cloud systems or servers. See, the billions of edge device. What is the advantage? Advantage is that low latency. So when this your smartwatch on your body is working with your health, it is automatically real time taking the data from the user, and it is processing the data, and after that it is performing, okay, what is the health statistics, what is your BP 120 or 130 by 70 or 85, it can tell you. So it is processing real time. So if you want to do it in cloud, suppose there is no edge device, after sensing the data go to the cloud, and cloud will perform the operation, then it will send it to the edge devices. It will take at least uh, few minutes of time, right? Or maybe sometimes if the server is busy, it can take 1 hour time sometimes, right? But using these edge devices, we can perform this operation in a real-time fashion, very fast, ultra fast. So what is the advantage? So edge device along with the IoT, okay, they do not need to send for all the kind of operation to the cloud. So for example, in your college, say you have vice chancellor in UEM or IEM, or you have also principal, or you have HOD, or also you have class teacher. Age is like a class teacher. So maybe you have UM has, maybe IEM has maybe 200 class teachers, right? Only say maybe 10 heads, right? And one vice chancellor or director, whatever. Now, for any operation, if a student, suppose the student is your IoT sensors or something like that, any operation, student have to go to the cloud to vice chancellor. He cannot handle it because the server will be busy, right? IEM has maybe 10,000 students, so it is not possible to handle the operation. So all the thousand billions of devices, if we can perform the whole operation in the edge level, then what will happen? The processing will be faster, processing will be accurate, processing will be no communication cost. It will be happening in the locally, right? For example, nowadays our West Bengal government also started their policy, right? What they said, they are sending the services at doorstep. What is it called? Anyone can tell? All the services, all the
Duare
government.
shortcut.
Yes, Duare shortcut means here age is nothing but Duare cloud. Is it clear, madam? So we are not going to government. Government is coming to you in your locality, in your para or locality, in your panchayat. The device is coming. So these devices, your laptop or your mobile phone, is capable enough to handle these small queries. The small, say, suppose in your house we have one AC machine, one washing machine, and one, say, even my chimney, my kitchen chimney is also IoT enabled, right? I can operate all these small IoT enabled devices or my lights in my house using my mobile phone or my tablet. So my tablet is an edge device which can perform all the operations. So what you can conclude, that only for big data will go to cloud. For small size data, if the processing on the computing requirement is low, we'll always go for edge level. But the complexity is high or the data size is huge, then we'll go to the cloud. Else we'll come to the edge, right? So this is the basic working principle of edge devices. And mobile edge means the every mobile phone is mobile. Your smartwatch is also is mobile. Everything is mobile, mobility, right? We love mobility. We do not need land phones or land facility. We want everything on go, right? We want every facilities on your car, your refrigerator on the car, your mobility on the car, your video, movies, whatever you want to everything enjoy on the go, not static. So mobile edge computing with mobility is playing a major role in the present operation to perform the systems to be used in proper fashion, right? So this is called edge computing, right? So edge computing is so popular, very much popular nowadays, and IoT is only possible, and this operations of IoT like interoperability, heterogeneity handling, and various kinds of signal protocol handling is only possible because of these edge devices, right? So what is the advantage? If we summarize, low latency means it will be real time, delay will be less. Second advantage is that it gives flexibility, real time data. And third advantage is less communication cost, faster. Fast, we want faster response. Suppose you are doing certain operation, robotic operation, it needs real time data. Suppose you are driving two cars, autonomous cars, the sensors must perform in a real time fashion. So edge computing is playing a very major role to perform these operations on the go, right? So by this way, actually, all the steps, edge to fog and fog to cloud, all these process steps will work like this, right? Now, what I said, cloud has IEM has cloud, right? IEM cloud, right? or UM cloud? What you say, madam? Yeah, IEM cloud or UM cloud? Whatever.
So it's the IEM cloud.
IEM cloud, right? So you have
Yeah.
IEM cloud, right? So your mobile phone or your laptop, whatever you are using, is your edge device. Now the question is, what is the reason of fog? Fog is your some of the servers in your college or your department. Some computing capability which is greater than the edge device but less than the cloud is called fog. Fog is a nearby node to these edges, right? Sensor can directly go to the fog or directly go to the cloud based on the loads. How much data your sensors are generating. So your IEM, every department has some small servers. They are called fog nodes. And cloud is a large server. IEM cloud. You know, you have I've seen that you have a lot of capabilities, high speed, high operation cloud servers, right? At IEM. So question is when you go to the edge almost every time. When you will go to the fog, when edge is not capable enough to handle, the computational capability is not enough, then you will go to the fog. If fog is not possible, then we will go to the highest level, right? Generally, a class teacher solves the problem of a student, right? Isn't it?
Yes, sir.
Madam? Yeah.
That is how the hierarchy goes.
Yes. So if the teacher cannot solve it, then he send the forward the file to HODs, right? Head of the departments.
Yeah, actually, I mean, if the students come up with an issue, the class teacher first tries to solve it, then forwards it to assistant HOD, then again to HOD, and so on.
Yes. So all the class teachers are basically the ages. They are they are also computing. They have some certain limitations and some computational capability, right? Means they can give certain decisions or they don't have any financial decision, right? But HOD can take financial decision. So based on the complexity of the data, we can go to the HOD or we'll go to the highest authority, you know, the vice chancellor or principal of the college, right? So this is the hierarchy of the cloud, basic hierarchy. Okay. Now if you know if you can tell, I can ask you that whether the fog is always important required. No, answer is no. You can simply connect your all kinds of devices, your powerhouse devices, solar panel or your cards to the edges. See, you have multiple edges here, and from the edges we can connect the data to the cloud data centers. We call it edge cloud network. And Internet of Things connected with edge will go to the cloud. So this is called edge cloud network, where you can see there is no fog, no problem. From edge to, if edge is not capable enough to handle it, we will send the directly data to the cloud only, right? That is actually the motto of the full processing. So I have shown you that edge to fog and fog to cloud is also possible. Also from the sensor or IoT devices, edge to cloud is also possible. No problem. Both the operations are acceptable. Okay. Now, if you see the edge computing, see this picture. From this cloud computing, what you have studied for last 1 week, FDP here, I think you have gone through the history of this cloud computing. I worked in mainframe when 1999 I was in Cognient, 99 2000 that time. So Cognient is just beside your IEM, right? So I worked there in 1999. So I used to work in that IBM mainframe, right? It is a big, tall computer. Maybe many of you have not seen. When I entered the room of this Cognient, then I've seen that there's a tall tower, and someone is calling that is the computer. Okay. Generally, we are habituated with mini computer or small desktop or laptop. But earlier, mainframes are very popular, and the language we used to use COBOL. I can remember. I learned Java in our intake level, but C++, Java, C. But I used to work in COBOL in industry. Okay. So it's a mainframe. After that, mini computer or desktop came. In 2000, we get client server architecture. You know, client server, everyone know. One client is multiple clients can be connected to a server that can perform certain operation. Then 2010 the web came, right? Then it starts the disruption. In which year? 2014-15. Okay, I took this picture from Rajkumar Bhuya, and his group has drawn this picture. And this cloud, started in the year of 2015 and 2020. This IoT and edge becomes so popular, right? Edge computing and IoT is almost synonym, right? You know that sometimes people says that that they're actually fully synonym. My name is Devashish. Also have some nickname. Someone called me as Partho, right? I think Bhabri Madam, you also have a nickname, isn't it?
Yes, just like any other Bengali household, we all have two names.
Same. So actually,
Yes.
Edge and IoT is now use interoperability, right? So both are same. Both the Devashish and Partho is same, right? But this is actually synonym, edge computing and IoT. Only IoT is exploring with the help of edge computing. Otherwise, because this IoT device do not have the computing capability. IoT is very low power, low energy devices. Okay, so it happened the revolution 2020. So just 4 years before, right? Now we are heading towards the last level. Here up to 2030. No, I cannot say last, but in our for our research life, maybe it is the last 2030. We'll see quantum. Quantum is coming in a big way, and you'll be happy to know I started using this quantum in the year of 2005 to 2010. That time till date, quantum computer cannot be operated in a room temperature. So it is working in a, if you see the internet, you'll see the IBM cloud or quantum clouds. They're actually uh, they're actually working in the cryogenic temperature, minus 273 degrees centigrade. Just imagine if IUM want to open a quantum cloud in your center, the room temperature will be minus 273 degrees centigrade. Is it possible? Normally, no. And that is the reason quantum computing is failure in terms of the material development. Suppose in your laptop or your desktop, we have a lot of electronics, but quantum perspective, if you go to the perspective of quantum in 2030 or something like that, it is expected that quantum computing scientists will develop in room temperature. But no one knows what will happen after 5-6 years. But we are hoping that quantum computing will come to uh, everyone's domain here, and ultimately we'll be getting very high speed and high power operations to be handled by this system, right? Okay. And this why this quantum computing is so popular? Can anyone say why these quantum computers are so powerful? Why we are only talking about quantum cloud? Answer is, in our cloud we are working in 0 and 1 binary. Everyone know, right? In our digital electronics class or computer organization, wherever, whatever we do, programming and everything, your C programming, whatever we do in uh, 0 and 1 domain, right? But quantum computer, they have three states: 0, 1, and entanglement states. It is basically like a sphere. The data can be existing any place. So 0 and 1 can exist together. So it is a third state is available called entangled state. So as a result, it is a 3-bit, or we call it qubit. It has three states. In binary, we have two states. Quantum has three states. As a result, the quantum computers are so powerful. In our say 5-bit to say 32-bit to 33-bit, what is the increase? Only 1 bit increase. But in case of say quantum computer, it is say 4-bit to 5-bit. How much it is increased? 2 to the power 4 to 2 to the power 5. How much it is increasing? Can anyone tell? 2 to the power 5 minus 2 to the power 4. How much? What is the value? Just calculate 2 to the power 5 minus 2 to the power 4. How much is the increase in terms of data speed? 2 to the power 5 minus 2 to the power 4. Can anyone share or type?
Yes, sir. The answers are coming up actually in the chat box. 16.
Right? But in
It is
case
that.
of normal classical computer, which is not quantum, it is 4 to 5 means only 1 bit increase. But in case of quantum, it is coming how much? 16, right? So you can understand if it is increasing from 2 to the power 31 to the power 32, so huge amount of increase we can say, isn't it? So that is the reason these quantum computers are very powerful, very useful, and that is the reason everyone is talking about quantum. And I think this when quantum computing will come, your all the RSA and all the cryptographic algorithm can be broken in seconds. Believe it or not, it can be broken in seconds. That is the beauty of the whole system. Everything can be done in a fraction of second. So we are all thinking of new kind of computation or new kind of computing will come. Okay. But just for your information, some company like Google, IBM, they are giving limited access of this quantum cloud through online. That means as a user, I have to log through my laptop like this kind of web meeting. We are accessing that quantum computer through this web, and we are accessing the cloud environment, cloud services through this platform, and we are actually performing this operation. You know, we are going to the chamber of the quantum cloud where the device is kept at very low temperature and low pressure, minus 273 degrees centigrade. And we are accessing the quantum devices, that material, where the logic gates and everything is there, right? And that is the basically quantum cloud. We are getting the not quantum computer as a my laptop or desktop, but we are quantum cloud services just started from 2022-23, right? Last 2 years, I'm also a small user of this quantum from Amazon. Also, I'm using it for uh, that Azure. They're also giving some quantum access. Also, IBM Q is also giving the quantum cloud access, and it is unbelievably fast. Anyone use Google Colab, which programs takes sometimes it programs takes 7-8 hours, right? Isn't it? Anyone
Yeah,
use
yes,
Google Colab?
yes. I mean, I use it for some like if running for some machine learning algorithm and stuff like that.
So something how much time it takes Colab?
If it is a long program, deep learning program, a lot of layers are there, then it often takes up. And if the data set is huge, it takes up around 7 to 8 hours sometimes.
So that 7 to 8 hours here it will be done in only fraction of second. So we are calling machine learning to quantum machine learning, right? Cloud to quantum cloud. That is the actually the theme of this system. That cloud computing is now changed, right? And all the companies are now talking about quantum. Clear? Only problem is that that is acting only. We are getting the quantum service as a cloud. We call it quantum as a service or quantum function as a service. QFAS, right? And India government is also spending a lot of money for quantum. Also, I have seen this morning IEM also introduced quantum computing in your syllabus. I just seen the syllabus. So quantum computing is coming in a big way, and everyone is talking about ML, AI, right? The quantum machine learning also in a very interesting area. I also work in a small way in that area. I just started working for a couple of years. Okay. Challenging because you have to convert your normal machine learning algorithm to quantum machine learning algorithm, and we have to wait for some funding or access because this funding is without funding is not possible to get the quantum access. Very limited access. Okay. Only you will get 2 bit or 4 qubit, right? But in the market, 1,000 qubit is also possible. China, especially China, they develop 1,000 qubit, like in case of bit, we call it, in case of quantum, we call it qubit. Okay, quantum bit, qubit. So already I have discussed this. So see this one, this is very important. QFAS, quantum function as a service. You know that we had heard about SaaS, PaaS, yes, software as a service, platform as a service, and infrastructure as a service, right? In case of cloud computing, right? Similarly, we'll be using this quantum like a SDK, you know, as a quantum API gateway. We will be accessing the quantum clouds as a service. We call it QFAS. So when you're talking about mobile edge, you know this, we also call QMEC, quantum mobile edge computing. That is also possible. So what is mobile edge computing in terms of definition? Already I have discussed as so many things about edge computing. But mobile edge computing means mobile edge computing with mobility. Extra is the mobility. So multi-access edge computing, okay, or formerly known as mobile edge computing, is defined the architecture, the concept of cloud computing and IoT services to the cellular network. So in the cellular network, see, we are doing the computing using our mobile phones or mobile architectures. So mobile phones are capable enough in computing and also in mobility. And that is the general purpose of mobile edge computing, right? Not only your mobile phone, you know, nowadays vehicles also can compute. The cars, the moving cars, which is mobile in nature, connected to the edge devices, and mobile edge devices are connected to the cloud. From vehicular to the mobile edge computing to the cloud, all the steps are performed like this, from cellular network to mobile edge cloud network to this. So in our roadside unit, we call it RSU, we have the towers. And these towers, say suppose this tower, this can cover these three cars. After certain time, when it's after some distance, there will be another tower which will control the trucks and this and this. And also, all these MECs are also connected to each other, right? So by this way, actually, we are getting a vehicular edge computing ecosystem. Lots of papers are there for vehicular edge computing, or vehicle means already it has the mobility is one of the feature, right? Cars has wheels, and it can move, right? In case of mobile, you have to move, user have to move. But in case of vehicles, there is a car, there is a wheel, it can move automatically from one place to other place. So cellular network to this domain, all the processing is done very smoothly and very easily like this. Okay. So this picture you also see RSU to CC. CC means central controller. RSU means roadside units, towers. Towers has a computing capability. These are the edge devices, you know, and these cards are also the sensors, right? So what are the communications? RSU to CC, RSU to CC control station. Vehicle to vehicle communication. Two cars can also can talk to each other. Hey, how far is the distance? And keep the distance, or you know, one car. Nowadays we have autonomous cars. They are doing this real-time edge computing. Especially in case of autonomous cars, they are doing automatically real-time edge computing operations. Okay, so that by this way actually these RSUs to central control units, they are all the operations are actually happening like this, right? Regular servers, RRU, RHU, RHP, like this. These are the full ecosystem of vehicular edge computing or vehicular mobile edge computing. Actually, vehicular and mobile is all same, or we can simply call it VEC. VEC is a very common popular term called vehicular edge computing. And you'll be happy to know many of the cars are coming up with these VEC facilities. Unfortunately, in India, this facility is not installed, but many developed countries they already installed. And by that process, what is the advantage? Car to car communication, vehicle to vehicle communication becomes easy. Vehicle to roadside unit communication becomes easy. So these are the various operations which can be performed very easily in the roadside units, and by this way, actually, whole operations can be performed in a very efficient and seamless fashion, right? So this is the beauty of edge computing. And autonomous cars, already my brother stays in US. They also have they comes with the uh, driverless cars, right? Car autonomous and driverless. So they just only write to the car and say the destination, and actually these RSUs, they control the cars and they take the car to the required destination, right? So this is the beauty of edge computing or mobile edge computing. In this case of for vehicular, we call it VEC, vehicular edge computing. Okay. See, it is written VEC server. VEC servers are here. Basically edge devices. This is the intelligence. What is the signal? So actually, this controls the congestion. If the congestion is high in certain road, the car will be diverted to other areas, right? So sometimes you can see that car to car also we can offload the data. Offload means we can transfer the data from one device to other devices, one card to other card. So offloading is very important. If we cannot perform it, we offload the job to other devices. By this way, the computation is performed. Full computation is performed. Okay. Vehicle to roadside unit, vehicle to vehicle, vehicular communication. So these are the local computing is happening in this system. We can see. Right. So nowadays, car industry is mostly based on this vehicular edge computing, and the car industry is nowadays mostly software defined. And if I ask a question that how many uh, mechanical engineer or automobile engineers are working in a leading this kind of car companies, can anyone say what is the percentage? Well, it's 40% or 80%. Mechanical engineers, can anyone just wild guess? 40, 60, 80 mechanical engineers. Manu, are you there?
I'm here, sir, but I have no clue actually about
No
this.
clue, right? Generally,
No.
I'm giving you some clue. 10 years before, there was no software defined car. That time, all the cars, what we have seen that they actually, that all the cars, what you have seen uh, in the factory, mechanical engineers, automobile engineers are there, right? Nowadays, if you see the level of BTechs, that 80% students are studying in computer science or IT or whatever, right? So that is a trend also in the software industry, car industry also. Believe it or not, 60% is from software engineers. 60% is software engineer in any vehicular company, and all the operations are software defined, right? They also update the software in the cards, like our mobile phones. If you can update it, your card will be also updated. It's totally software defined. uh, Fault detection, also vehicular communication, this edge computing, everything is computation is performed. So it is totally software defined ecosystem with the vehicular or roadside units, which performs all these kinds of operation for various edge computing scenario, right? So when we'll offload, when your card is not capable enough to handle, then we'll offload. Offload means you are giving someone to solve on behalf of you, right? Which is more powerful. Maybe this red card is more powerful compared to this green card. So this V2V, when vehicle to vehicle communication is happening, and this local computing is happening in the red card. Maybe it has more RAM or more updated software. After the computation, the result will go to the green card, right? So this is called vehicular communication, V2V communication. That means the job which is in hand of this green card is not capable to do it. So it is taking the help of the red card. After this V2V offloading, this local computation is happening in this red card, and the result will go to the green card. But computation is happening in the locally in the here in this red card. So this is called edge computing. Here, okay. So within the vehicle, it's possible vehicle to Roadside internet is also possible. Even all the cards, maybe the data size is very high, so edge is not possible, so it will send the data to the RSUs. So by this way, actually, all the computations are happening in the vehicular network, and this is coming in a new standard for vehicular communication. If you see the journals like Elsevier, vehicular communication, or IEEE transaction on intelligent transport system or vehicular communication, you'll see all this kind of things are available there, and they're performing this operation like this. Okay. So I have written one book 2 years before, 22, which is on mobile edge computing. There are around 22 chapters are there. I think it's freely available in Springer link. I think IEM has access. You can simply download it. Those who are interested in the domain of edge computing, especially in mobile edge computing, where the mobility playing major role, they can go through this architecture, all the hardware, software requirements, all the offloading techniques, whether it's vehicular, whether it's agriculture, everything is written there, right? Now the question is, we are all talking about cloud, and this cloud is actually controlled by AI, right? Now there is a question: cloud for AI or AI for cloud? Both the answer is correct. Cloud for AI and AI for cloud means that in the remote, see, cloud AI means cloud is providing the AI service to the remote remote systems. So this is called cloud computing, right? But in case of edge computing, every edges they have intelligence. We call it AI edge. Cloud AI was there earlier in cloud computing. Now we are distributing the intelligence. We are giving lightweight machine intelligence. You know that machine learning techniques, training, testing, whatever you do, in the local servers, and ultimately we are performing this operation like this. This is called edge computing. This is called cloud computing. This is called edge computing. Okay, clear? Edge computing is something like that. We are distributing. Amra shobai raja. Actually, edge computing principle is that it is not centrally controlled. It is that Rabindranath says that Amra shobai raja. Amaderi raja rajatte. So edge computing is something like that. Everyone can compute. Everyone has intelligence. Okay. So we have also written one book called AI for IoT, along with Raj. This are also one book on IoT, where Rounak is also there. So just like to mention this one that yeah. See, when you are talking about intelligence, intelligence has 3 levels in case of edge. So first level of intelligence to the edge devices called terminal intelligence. Second level to the base stations called local intelligence, and very high end algorithm, deep learning, and so complex algorithms, reinforcement learning, whatever, they are coming under centralized intelligence. So if your operation is in local level, we are working on terminal intelligence. So using this cache memory, you are performing this operation in the terminals. If the computation is, we need more computation, then we go for local intelligence. Else we will go for centralized intelligence. Centralized intelligence can handle huge data, huge amount of computing capability, but lightweight intelligence is given to the terminals like cars, like your mobile phones, like your tablets, like your vehicles. You know that your smartphones, or actually smartphone means intelligent phones, right? Or smartwatch, we call it intelligent watch, which can measure your body statistics. Apple smartwatch or Samsung smartwatch. If you buy, you can get all kind of health parameters on it. So we are getting actually the terminal intelligence in the smartwatches, right? So already we are using it, and this is commercially available as a consumer product, right? So do not think edge computing will come. It's already came with us, and we are using it daily, right? Those who use smartwatches or smartphones, this intelligence, terminal intelligence is part of it, right? All the softwares, all the hardwares, all the firmwares are stored there. All kinds of sensors are there, right? Even our drones or the vehicles, even the drones are playing major role. So drones have their own intelligence, level of intelligence, right? So when we are talking about IoT, Internet of Things, or simply we can say the edge computing, we will be mostly concentrating on the terminal intelligence. And those who are interested in machine learning research, I can tell you, start on this area, terminal intelligence or edge intelligence. Okay, madam, is it okay?
Yes, sir, absolutely.
So can I say Duare intelligence?
Yes, I was just going to that.
So we are giving intelligence at the doorstep of the user using these edge devices, right? I try to think in our own way so that we can simply understand the subject, right? So I call it intelligence at the doorstep or Duare intelligence, whatever you say. Okay, okay. Next, I'm going to the top trends of edge technologies. There are around 1,648 startups that we have observed in edge devices throughout the world, and the most important is the edge AI. Intelligence and edge is working together. Then comes for the 5G. 5G is playing a major role. Then Internet of Things. 5G, you know that 5G is already Airtel and Jio started giving 5G services, right? Then we are having this Internet of Things, IoT. Then we are having edge analytics. You know, like data analytics, we also have edge analytics. Edge analytics is a big subject itself. Also, the blockchain. You know, the blockchain has a lot of power issues, but still, blockchain is used for providing the security using this exchange of hash functions. Multi-access edge computing, MEC, edge data centers, IoT convergence, IoT to IoT convergence, data security. Data security is very high in edge because you do not have to travel from edge to fog to the cloud. So as all the operations are performed at the edges, so security and privacy perspective, edge devices are much more security level is higher. Level of security is higher, right? Very, very high. So if you see the market share, edge AI is 25%. 5G, they are also uses AI around 25%. Also, IoT uses 70% of these edge computing capabilities. Edge analytics 10%, blockchain 8%. Blockchain is facing a little bit power issues in the edge devices because we also published one paper in IEEE transaction on consumer electronics, lightweight blockchain. It is already published last month. So those who are interested, they can go through this. So these are the various sectors that industry is using this edge computing rigorously in our in their devices, right? Edge computing becomes a fashion or trends like IoT. No, it is a fashion. Okay, so we have already said that all the things, and let's see the applications. So most of the most important application is the patient care, healthcare sectors, right? See, patient is in a certain bed, right, in a hospital, but doctors can monitor or nurse can monitor the patient. Say one nurse with is given 20 beds. So using the bed statistics nowadays, the patient beds. If you go to any good hospital, I'm not telling any name of the hospital, but any good hospital, they are coming up with IoT enabled.
பட் ஆனா இவங்க இதுல டீமே இல்ல வெண்ணிலாக்கு பிரேம்லதா.
Yeah, they are using IoT enabled beds, right? And through that IoT enabled beds, the nurse or doctor can monitor the patient very easily using this edge computing, because this bed is doing edge computing. We call it edge bed, intelligent edge bed. Mind it, they can measure the health parameters, and if anything is wrong, simply the red signal or the big message will come to the doctors or the nurse, so they can take immediate action to the patient, right? Also for fraud detection, traffic management. Already I've discussed many things about traffic management. Fraud detection is very easy because all the operations are happening locally, so fraud detection becomes much more easier. I also work in extensively in crop monitoring. I have, you'll be happy to know I have 4 patents on IoT based edge devices we develop certain edge devices for crop monitoring. Okay, various kinds of crop monitoring. Okay, so edge devices are developed with high computing capabilities and crop monitoring, and many farmers, we call it precision agriculture. Precision agriculture is only possible or due to the mobile edge computing only, right? We are giving the intelligence to the farmers so that their crop production become double or at least higher, right? So real-time video analytics, if you see the Euro or World Cup football, the football comes with IoT sensors. Whether Ronaldo is given kick or not on the head, whether the ball is handball or not. In Maradona case, it was very difficult to detect. But real-time video analytics can also find out the collision between 2 cars. So everything can be done in the edges, right? Who is the mistake? Who is doing mistake? Everything can be found using this video analytics. Okay. And also in roadside units, you know that various traffic signal roads, they uses this real-time videos. They also in Airport Authority of India, they are using various kinds of operation extensively in the roads. Okay. Also another thing is better power supply management, better supply chain management in the in Pantaloons or Geo or Big Bazaar. They uses also power supply management, power chain management or supply chain management. So there are various applications of edge computing, and they are increasing day by day in almost all the sectors. Okay. So anyone heard about neuromorphic edge? Neuromorphic edge is another very interesting area. So, madam, have you heard about neuromorphic computing?
No, sir, I haven't.
Okay, let me explain in very simple, lucid language. So, what you have heard, you know the von Neumann architecture in our architecture paper class.
Yes,
Right?
yes, yes.
So, what is there? There is an input, there is an output, there is a CPU, and below the CPU there is a memory, right? Agree?
Yes, agreed.
I'm repeating again. One is input, right side there is output, there is a CPU, and below the CPU there is a memory. Memory and CPU is separate. Up to this, okay?
Yes, sir.
Now, it is observed that after observing this brain signal in our human brain, that signal comes like a pulse, and the memory is not part of memory is not outside CPU. So scientists are building now the memory within the CPU, right? So it is also known as in-memory computing, and computation becomes extremely fast. Clear? And this is known as neuromorphic computing. So memory is within the CPU, and so
Sir,
CPU
it is
and memory.
something. Sir, it is something like mimicking the human brain.
Exactly. So exactly it is observed when the scientists observe the human brain. So they have observed memory and CPU is not separate. If they separate, they cannot give real-time data. But what I've said in the throughout last 1 hour, that edge computing gives real-time data, right? So for real-time processing, real-time intelligence, we need to work like a brain. So this is known as neuromorphic architecture, where the CPU and memory is working together. Memory is within the CPU. So this is also known as in-memory computing, or in terms of edge computing, we call it neuromorphic edge computing. We are mimicking the brain, right? Brain, what happens? Suppose there is a mosquito in your hand. So what will happen? Your other hand will come and kill the mosquito, right? So like a pulse of signal will come. Okay, your mosquito is biting your left hand. It go to the signal to the brain, and computation and memory processing happens. Immediately, it gives the signal to the right hand. Okay, kill the mosquito with your right hand. So it is like a another spike like this. So this is also known as spiking computing. Spike, we heard about neural network, right? ANN, right? Artificial neural network.
Yes, yes.
So in case of neural morphic computing, we call it SNN, spiking neural network. Okay. And this spiking neural network is ultra fast. So whatever you are doing, it can be giving ultra fast operation, and this is mimicking the neurons. So this is known as neuromorphic edge computing. So future belongs to the cloud and AI. There is no doubt about it. I just like to conclude here that this in-memory computing, edge computing, neuromorphic computing, and the AI will govern our life. And we hope that we'll be working together. Anyone is interested, we can work together, no problem. To develop this cloud, especially this kind of architecture, neuromorphic architecture, a lot of scientists are working on this neuromorphic computing, static neural network, to develop the ultra fast cloud computing operations and ultra fast and intelligent cloud computing. So the future belongs to the cloud and AI. Thank you.
All right. Thank you very much, sir. Thank you so very much for giving us the latest trends and technologies that are going on in the field of edge computing. I mean, for me personally, neuromorphic edge computing is something I'm coming to know right now. I didn't know about it. So, thank you very much for enlightening us. To the participants, I would request you to put up your questions in the chat box if you have any. There are many compliments coming your way, sir. Excellent session. All right, I have a question from Professor Anindita Das Bhattacharjee. Suppose some of the IoT devices, say it is in the kitchen chimney, stops functioning, then to replace it, how much headache will be there in terms of finance or technologically speaking? Like, what is the lifetime that we are having?
I'm just telling you, very interesting question. When a message will come to me that my kitchen chimney is not working, okay, I'll simply forward it my message to the customer, means customer care. They will try to do it remotely. They will access my chimney with their IP, right, remotely. 90% problems are solved remotely. Maybe some malfunction or software update. They do it remotely and they solve the problem. Till the problem is in the hardware, then they will come and solve it. So I don't have to do a single phone call for it. So everything will be automatic. Okay.
All right. Thank you, sir. Sir, I have one question actually. I mean, since I attended all the sessions, so I mean, this one from our colleague as well. That if I mean, whether quantum and age both can coexist together in the long term.
Yes, yes, very good question. Actually, I have one project from ICRB on quantum edge. I have the fund for it. So, so that gives the answer of your question, that we are working, we want to bring quantum at the edge. Okay.
All
Actually,
right.
what I said, quantum computing, madam, listen very carefully. Quantum computing is not like a laptop or your mobile phone. It is working in low temperature, right? Somewhere in a confined room, right? Maybe in Australia, maybe in Italy, or maybe in Germany. I am accessing it through the cloud, right? So if your edge device connected to the internet, if you have the IP access, then your edge can be controlled, right?
Right, sir.
For example,
Yes.
maybe in a country like India, maybe they have say 1 lakh drone. If country like India, they government want to handle all the drones by manually, it may take a lot of computational power. But if you do it using quantum server, it will be done in fraction of second. Maintenance management becomes faster, right?
Right. Right. So we will be saving time as well as resource, money, everything.
Everything, everything.
Yes. Okay. We have one question from I think our participant's name is Mr. Tirthankar Ghosh, and the question is: since everything is based on internet, so what happens if the connection is lost? Do we lose track of all the devices?
I think, yeah, I have not mentioned here. I have one book called Due Computing. I'm also the vice chairman of IEEE Due Computing Society. So if you go through my book called Due Computing means that every device there is a cache memory, right? If your cache is there, cache is enough to handle the operation. If the internet connection is lost for 30 to 40 seconds, it can hold the data. There will be no connection loss. So in that case, problem will not be there. But If the connection lost for 5 minutes, then the problem will be there. So when you want to buy a mobile phone like this, any mobile phone you want to buy, you have to be careful. If you're buying any Apple phone or Samsung high-end S series phone, then cache memory is high. Maybe everyone will lose connection, maybe you will not lose connection because your phone has higher cache memory, right? Cache memory is very important. This is also known as edge-based cache. Those who are interested, they can go through my Springer book called Dew Computing. Just published this year, 24, yeah. It's
All
published
right,
by
sir.
Springer.
Okay. I think we will all be looking forward to reading that book.
Yes.
To all the participants, if you have any more questions, please put it up in the chat box for sir to give you the answer. In the meantime, sir, with your due permission, I would like to share my screen once.
Yes,
I
yes.
mean, had it been an offline session, it would have been great for us to meet and greet you in public and
Yes.
to present the small token of appreciation from our end. Since it
Sure.
is not possible, so this is a very small token of appreciation. I thank you wholeheartedly on behalf of the organizing committee for giving this wonderful lecture in the 5 day long faculty development program. I hope you like the certificate, sir.
Sure, sure. Excellent. Thank you.
Okay. Thank you, sir. Thank you very much. So, yes.
Thank you.
So, with this, we are coming towards the end of the session. Any more questions? Do we have any other questions? I don't see other questions. All right.
Yes.
So,
Thank you.
with this, we can end the session. I will be just, doing a small, giving a small note of, vote of appreciation, and I would like to thank, uh, the organizers. So, just 2 minutes of everyone's time, if that is okay. So, with this, we come to the conclusion of this enriching 5 day long faculty development program on emerging trends and challenges in cloud computing and IoT. And it is my privilege to extend a heartfelt vote of thanks. Firstly, I would like to express my deepest gratitude to our esteemed speakers. For 5 days, they have, spent so much time, resource, and has shared their insight on the topic. So, Dr. Sharbani Roy was there with us, Dr. Tanushyam Chattopadhyay, Dr. Sunilmal Khatua. Yesterday we had Dr. Josna Kumar Mondol, our very own JKM sir, and today we are so grateful to have Dr. Devashish Dev with us as well. Your insights and expertise have provided invaluable knowledge and have greatly contributed to the success of this program. I would also like to extend my sincere thanks to Director Sir, the patron of this event, Dr. Satyajit Chakrabarti, for his unwavering support and encouragement. Sir always gives us a free way for organizing this kind of events for the development of the students and the faculty. A special thanks to our convener and head of the department, Professor Dr. Moutushi Singh, whose dedication and meticulous planning ensured the smooth execution of this event. I would also like to thank the organizing committee members. I am there. Along with me, we have Professor Shubhasri Roy, Professor Shreejita Mukherjee, Professor Rounak Saha, and Professor Apurba Pal for their hard work behind the scenes. Your efforts have been instrumental in making this event a grand success. We would also like to thank Professor Dr. Shukana Mukherjee, Assistant HOD of CSE Department, for her continuous support throughout the event. Our gratitude also goes out to the HRDC department of IEM-UEM group and the main contributing factor, the IEEE Computer Society IEM student branch chapter, for their collaboration and support. Lastly, a big thank you to all the participants for your active involvement and enthusiasm. Your engagement has made this FDP a truly interactive and rewarding experience. We hope that the knowledge and the insights gained during this program will be beneficial in your professional endeavors. We look forward to your continued participation in future events. Thank you to all. With this, I think we can end today's session. As I have mentioned earlier, the assessment of this 5 day long FDP will be held tomorrow, details of which will be shared in the official WhatsApp group in due course of time. So with this, I think we will be ending the session as well as the 5 day long FDP today, right here. Thank Thank you very much. Thank you all for your unwavering support and your continuous encouragement. Thank you. We will keep the session open for another 5 minutes, possibly. In the meantime, I would request all participants to